When we reach an understanding that the primary disorder is metabolic acidosis, the next step is to decide if it is high anion gap metabolic acidosis or normal anion gap metabolic acidosis, or mixed. So you might be asking yourselves, is there a true anion gap in the body? Well, the answer is no. There is no actual gap in the body. The human body maintains electrical neutrality. Every positive charge, cation, has a corresponding negative charge, anion. There are cations that we calculate, namely sodium, and uncalculated cations. Similarly, there are anions that we calculate, namely chloride, bicarbonate, and uncalculated anions. Potassium, calcium, and magnesium are not included in the anion gap calculation. Similarly, phosphate, sulfate, and plasma proteins that carry a net negative charge are not included, because their plasma concentrations are relatively low and stable compared to sodium, chloride, and bicarbonate. The quote-unquote gap we calculate is simply due to the fact that our routine lab tests do not measure all anions or even all cations. The anion gap just helps us estimate the presence of unmeasured anions. So the anion gap is a calculated value, not a real physical gap in the bloodstream. There is a consensus regarding which ions should be included in the calculation of the anion gap for determining acid-base disorders. The anion gap is typically calculated using the formula anion gap equals sodium minus the sum of chloride and bicarbonate. On the other hand, albumin, a negatively charged molecule or anion, is included in the corrected anion gap calculation. Therefore, hypoalbuminemia can affect the anion gap. To account for this, the anion gap can be adjusted for albumin levels using the following formula. Corrected anion gap equals anion gap plus 2.5 times 4 minus albumin. This adjustment is important because hypoalbuminemia can mask a significant increase in unmeasured anions, leading to an underestimation of the anion gap. Correcting for albumin ensures a more accurate assessment of the acid-base status. So when organic acids such as lactic acid or keto acids are added to the blood, bicarbonate is lost to maintain electrical neutrality. As bicarbonate decreases, the anion gap increases, indicating the presence of unmeasured anions, which is characteristic of high anion gap metabolic acidosis. Contrary to high anion gap metabolic acidosis, when there's a loss of bicarbonate, the body compensates by increasing chloride levels to maintain electrical neutrality, a condition known as hyperchloremic acidosis or normal anion gap metabolic acidosis, or non-anion gap metabolic acidosis. This is a type of metabolic acidosis characterized by a normal anion gap, typically between 8 to 12 milliequivalents per liter.